You think modern trucks are beasts? Think again, because some of these old machines were putting down numbers that would embarrass half the pickups sitting on dealer lots today. No fancy turbos, no computer tricks, just raw, brutal engineering that Detroit refuses to talk about. These forgotten legends didn't just haul loads, they destroyed expectations. Stick around because 3 will genuinely shock you. Number 1. Kenworth W900. The Kenworth W900 is one of the most enduring and power-focused semi-truck designs ever built, and its reputation for raw strength is not accidental. From the moment it was introduced in the early 1960s, the W900 was engineered around one core idea: make room for the biggest engines available. The long hood, heavy steel frame rails, and spacious engine bay were not styling decisions, they were mechanical necessities for fitting massive displacement diesel engines that simply would not fit in shorter, more compact tractors. Throughout the 1960s, 1970s, and 1980s, the W900 was routinely equipped with engines that prioritized torque over refinement. Caterpillar 3406 engines, Cummins NTC Big Cam series, and Detroit diesel two-stroke engines were all common choices. These engines produced enormous low RPM torque, which is the true measure of pulling power in heavy hauling. While modern trucks often advertise higher peak horsepower numbers, they are electronically limited and tuned to meet emission standards. Older W900s, by contrast, delivered power mechanically. Fuel racks, injectors, and turbochargers worked without computer intervention, allowing full torque delivery as soon as the throttle was applied. Another key reason the W900 could be more powerful than many modern tractors lies in gearing and driveline configuration. Older W900s were commonly paired with 13-speed or 18-speed manual transmissions and low rear axle ratios. This combination allowed drivers to multiply engine torque effectively at low speeds, making the truck exceptionally capable when starting heavy loads or climbing long grades. Modern automated manuals and tall gearing favor fuel efficiency, not maximum tractive effort. The W900 also became the platform of choice for owner-operators who wanted maximum power. It was common to uprate engines beyond factory settings, especially in the pre-emissions era. Fuel delivery could be increased, turbochargers upgraded, and cooling systems reinforced, all without triggering electronic safeguards. As a result, many older W900 produced torque figures that rival or exceed modern production trucks in real-world hauling conditions. Even today, restored and working W900s are frequently used in logging, heavy haul, and specialized transport. Their continued presence is proof that the model's power-first design philosophy created a truck that remains mechanically formidable decades later. Number 2. Peterbilt 359. The Peterbilt 359 is often regarded as the purest expression of old-school American trucking power. Built between 1967 and 1986, the 359 was not designed to be aerodynamic, fuel-efficient, or electronically sophisticated. It was designed to pull heavy freight reliably day after day, using the largest and strongest engines available at the time. What made the 359 genuinely powerful was its ability to house extremely large mechanical diesel engines. Caterpillar 3406 inline-six engines were among the most popular choices, valued for their durability and massive torque output. Cummins NTC Big Cam engines were also widely used, delivering strong low RPM pulling power, ideal for heavy loads. These engines did not rely on electronic controls. Instead, they used mechanical fuel systems that responded instantly to throttle input. The long hood of the 359 was critical. It allowed for larger radiators, improved airflow, and more robust cooling systems, all essential when engines were tuned for maximum output. In many cases, owners deliberately chose conservative factory horsepower ratings and then uprated the engines later, improving longevity while still extracting tremendous torque. This flexibility simply does not exist in modern electronically controlled engines. Another reason the Peterbilt 359 could outperform modern trucks is driver control. The 359 was almost exclusively paired with manual transmissions, often 15 or 18-speed units. Drivers had full authority over gear selection, engine braking, and torque management. In difficult terrain or heavy hauling situations, this level of control allowed experienced drivers to keep the engine in its strongest torque band, something automated systems cannot always replicate. Structurally, the 359 was overbuilt. Thick steel frame rails, heavy suspension components, and robust axles meant it could safely transmit high torque to the ground without driveline stress. Many modern trucks optimized for weight savings and efficiency are not designed for sustained maximum torque operation. The enduring popularity of the 359 in restoration and working fleets is not nostalgia alone. It is recognition that this model represents a time when semi-trucks were engineered with one priority: unrestricted mechanical strength. Number 3. Peterbilt 379. The Peterbilt 379 carried forward everything that made the 359 powerful and refined it into a modern classic. Introduced in 1987, the 379 became the definitive long-hood semi for owner-operators who demanded both prestige and extreme pulling capability. Its design retained the long hood specifically to accommodate the largest and most powerful engines on the market. Throughout its production run, the 379 was commonly fitted with Caterpillar C15 and C16 engines, some of the most powerful on-highway diesel engines ever offered in production form. These engines produced exceptional torque, particularly in pre-emissions configurations, where power delivery was unrestricted by exhaust after-treatment systems. Cummins N14 and early ISX engines were also popular, known for strong mid-range torque and durability under heavy load. What sets the 379 apart from modern trucks is how its power was delivered. The torque curve was broad and aggressive, meaning usable pulling force was available well below cruising RPM. This made the 379 exceptionally strong in heavy haul and mountain operations. Modern engines may advertise higher peak horsepower, but that power often arrives at higher RPM and is moderated by electronic controls to protect emissions components. The 379 also benefited from heavy-duty driveline options. Buyers could specify heavy axles, deep rear-end ratios, and multi-range transmissions. These configurations multiplied torque mechanically rather than relying on software. In real-world terms, this means a loaded 379 could start heavy freight on steep grades more confidently than many modern fleet-spec tractors. Culturally, the 379 became synonymous with power. It was the truck chosen by drivers who wanted the strongest engine available, regardless of fuel consumption. This mindset led to a concentration of high-output engines in 379 chassis, reinforcing its reputation as one of the most powerful production semi-trucks ever built. Number 4. Mack R-Model. The Mack R-Model represents a fundamentally different definition of power, one rooted in usable torque rather than peak horsepower. Introduced in 1966, the R-Model coincided with Mack's revolutionary Maxidine engine philosophy, which permanently changed heavy trucking. Unlike competitors that chased ever higher horsepower numbers, Mack engineered the Maxidine engines to produce a flat torque curve. This meant the engine delivered near constant power across a wide RPM range. In practical terms, an R-Model could pull heavy loads up long grades with far fewer gear changes, maintaining momentum where other trucks struggled. The Maxidine engines were not the most powerful on paper, but they were brutally effective. Torque was available almost immediately, and drivers could operate with fewer shifts and less drivetrain stress. This made the R-Model exceptionally strong in logging, construction, and regional heavy haul work, applications where modern trucks often feel restrained. Another reason the R-Model could outperform modern tractors lies in its simplicity. Mechanical fuel injection, minimal electronics, and robust cast-iron construction allowed the engine to operate continuously under heavy load. There were no emission systems to derate power, no software limits to protect exhaust components. The engine delivered exactly what the driver demanded. Structurally, the R-Model was massively overbuilt. Mack designed and manufactured nearly every major component in-house, ensuring compatibility and strength. Axles, transmissions, and frames were designed to handle sustained torque output without fatigue. Even decades later, many Mack R-Models remain in active service, particularly in vocational roles. Their continued use demonstrates that power is not only about numbers, it is about how effectively an engine can turn fuel into unstoppable forward motion. Number 5. International Transtar 4300. The International Transtar 4300, particularly in its Super Transtar configuration, stands as one of the most brutally powerful factory-era semi-trucks ever offered. Unlike many tractors that gained power reputations through later modifications, the Super Transtar earned its status directly from factory-approved extreme engine options, most notably the Detroit Diesel 12V71 V12 two-stroke engine. The 12V71 was an enormous engine by on-highway standards. With 12 cylinders and massive displacement, it delivered exceptional torque at low RPM, which is the defining characteristic of true pulling power. While its factory horsepower ratings varied depending on configuration, the real strength of the 12V71 was its torque curve. Power was available almost immediately, allowing the Transtar to move extremely heavy loads from a dead stop with authority that many modern trucks simply cannot match without slipping clutches or electronic intervention. International designed the Transtar 4300 with this level of power in mind. The chassis featured heavy steel frame rails, reinforced crossmembers, and driveline components capable of handling sustained high torque. Cooling systems were oversized, recognizing that large two-stroke engines generated substantial heat under load. These design choices allowed the Super Transtar to operate in severe conditions such as heavy freight corridors, oversize hauling, and industrial transport roles. What truly separates the Transtar from modern trucks is the absence of electronic limitation. Modern engines continuously monitor exhaust temperatures, emissions components, drivetrain stress, and traction conditions, reducing power output when thresholds are approached. The Super Transtar had none of these constraints. If the driver applied throttle, the engine delivered fuel, pure mechanical response. Another factor contributing to its power advantage was gearing. Transtar 4300 trucks were commonly paired with deep rear-end ratios and multi-speed manual transmissions, maximizing torque multiplication at low speeds. This made them exceptionally effective on grades and in stop-and-go heavy hauling, where modern trucks often feel muted or delayed due to electronic throttle mapping. The Super Transtar's reputation was so strong that it became a benchmark for raw highway power in the 1970s. Even today, surviving examples are remembered not for comfort or efficiency, but for their ability to move weight without hesitation, a quality that defines genuine mechanical power. Number 6. Ford LTL 9000. The Ford LTL 9000 is often overlooked in discussions of powerful classic semis, yet it was one of the most formidable long-hood tractors of its era. Introduced as part of Ford's Louisville heavy truck lineup, the LTL 9000 was engineered to compete directly with Kenworth and Peterbilt in the high-power owner-operator market. The defining feature of the LTL 9000 was its ability to accommodate large, high-torque engines. Cummins big cam engines were among the most common heavy-spec options, known for their strong low RPM torque and mechanical reliability. Caterpillar 3406 engines were also frequently installed, giving the LTL 9000 access to one of the most respected heavy-haul power plants of the time. What made the LTL 9000 especially powerful in practice was its weight and rigidity. Ford built these trucks with thick frame rails and robust suspensions, allowing them to transmit high torque to the ground without driveline flex or component fatigue. This structural strength meant drivers could fully utilize engine output without fear of mechanical failure, something not always true in lighter modern tractors. Another advantage was Ford's straightforward mechanical engineering philosophy. There were no electronic throttle controls or engine derates. Power delivery was direct and predictable, giving drivers precise control over torque application. In heavy hauling situations, such as starting loaded trailers on inclines, this immediacy translated to superior real-world performance. The LTL 9000 was also commonly geared for pulling rather than speed. Lower axle ratios and multi-speed manual transmissions allowed drivers to keep the engine squarely in its torque band. Modern trucks, optimized for fuel efficiency and emissions compliance, often use taller gearing that reduces available tractive effort at low speeds. Although Ford eventually exited the Class 8 market, the LTL 9000 remains respected among classic truck enthusiasts for one reason: it was a serious workhorse, built to pull hard and continuously. In direct heavy load comparisons, a properly spec'd LTL 9000 can still outperform many modern tractors where torque, not technology, determines success. Number 7. Volvo F16. The Volvo F16 represents Europe's answer to extreme highway power. Introduced as the flagship of Volvo's F-Series, the F-16 was designed to dominate long-distance heavy hauling across mountainous European roads, where sustained torque and durability mattered more than outright speed. At the heart of the F-16 was Volvo's TD162 engine, a large displacement inline-six diesel developed specifically for high torque output. This engine was among the most powerful production truck engines available in Europe at the time. Unlike many modern engines, the TD162 delivered strong pulling power at relatively low RPM, making it ideally suited for heavy loads on steep gradients. The F-16's cab-over design may appear compact, but the chassis and drivetrain were anything but light-duty. Volvo engineered the truck to handle continuous high loads, with reinforced frames, heavy axles, and transmissions designed for sustained torque. This allowed the F-16 to maintain momentum where lesser trucks would require frequent downshifts or power reduction. One reason the F-16 can feel more powerful than modern European tractors is its lack of electronic restriction. Modern EU trucks are tightly governed for emissions, noise, and fuel efficiency. The F-16, by contrast, delivered its power mechanically and consistently, allowing full output whenever demanded by the driver. The truck became especially popular in heavy haul and international freight operations, where reliability under load was critical. Operators valued the F-16 not just for its power, but for how long it could sustain that power without overheating or derating. Even decades later, the Volvo F-16 is remembered as one of the strongest European highway tractors ever built, a machine that prioritized torque endurance over electronic optimization, a philosophy that modern trucks have largely abandoned. Number 8. White Road Boss. The White Road Boss was aptly named. Built by the White Motor Company, this long-hood conventional was designed to project authority, not just visually, but mechanically. During the 1970s, the Road Boss represented White's commitment to producing a true heavy-haul tractor capable of handling the largest engines and toughest jobs of the era. The Road Boss was offered with a variety of large diesel engines from Cummins, Caterpillar, and Detroit Diesel. These engines were chosen for their torque characteristics rather than peak horsepower figures. In practical terms, this meant the Road Boss excelled in heavy freight movement, construction hauling, and vocational transport, where continuous pulling force was essential. Structurally, the Road Boss was massively overbuilt. Thick steel frames, heavy suspensions, and industrial-grade axles allowed it to absorb and transmit high torque without fatigue. This made it especially suitable for engine uprating, a common practice among operators seeking more power. Mechanical fuel systems allowed tuning without electronic intervention, giving the Road Boss a flexibility modern trucks lack. Another key factor was driveline simplicity. Manual transmissions and mechanical throttles gave drivers direct control over engine output. There were no traction controls, torque limiters, or emissions-related power reductions. The truck delivered exactly what the engine produced, making it feel brutally strong under load. The White Road Boss never achieved the cultural fame of Kenworth or Peterbilt, but among professionals it earned respect as a serious pulling machine. In real-world hauling, especially under heavy weight and low speeds, a Road Boss could outperform many modern tractors that prioritize efficiency over raw mechanical strength. Number 9. Freightliner FLD120. The Freightliner FLD120 is often underestimated when discussing powerful classic semis, largely because Freightliner later became synonymous with aerodynamic fleet trucks. However, the FLD120 represents a very different era, one where Freightliner built serious long-hood tractors designed to house the biggest engines available and compete directly with Kenworth and Peterbilt in the high-power market. Introduced in the late 1980s, the FLD120 featured a long hood and heavy-duty chassis capable of accepting large displacement engines such as the Detroit Diesel Series 60, early mechanical versions, Cummins N14, and Caterpillar 3406 variants. These engines were known for their strong torque delivery, especially in pre-emissions configurations where fuel delivery was not electronically restricted. In real-world hauling, torque, not peak horsepower, is what moves weight, and the FLD120 delivered plenty of it. One of the reasons the FLD120 could be more powerful than many modern tractors lies in engine accessibility and tuning freedom. Mechanical Series 60 engines and early Cummins N14s could be uprated for higher fuel flow, improving torque output significantly without triggering electronic safeguards. Modern engines, by contrast, will derate or shut down when parameters exceed emission or thermal limits. Structurally, the FLD120 was built to endure. Its frame rails were thick, its suspension robust, and its drivetrain components sized to handle continuous heavy loads. This allowed the truck to fully exploit engine output without long-term structural stress. Many FLD120s were specced with deep rear axle ratios and 13 or 18-speed manual transmissions, giving drivers the ability to multiply torque effectively at low speeds. Another critical advantage was driver control. With a mechanical throttle and manual transmission, the FLD120 placed power management directly in the hands of the operator. In heavy hauling scenarios, such as mountain grades or start-stop freight movement, this allowed experienced drivers to keep the engine precisely within its strongest torque band. Today, the FLD120 is remembered as Freightliner's last truly old-school long-hood brute. When properly specced, it remains capable of outperforming many modern tractors in low-speed, high-load situations where raw mechanical strength matters more than software optimization. Number 10. Western Star 4800. The Western Star 4800 is one of the most underrated yet brutally capable heavy-haul semi-trucks ever produced. Built during a time when Western Star specialized in custom, vocational, and extreme-duty trucks, the 4800 series was engineered not for mass fleets but for operators who needed uncompromising strength. What immediately set the Western Star 4800 apart was its long hood and massive engine bay, which allowed it to house some of the largest diesel engines available. Caterpillar 3406 and later C15 engines were common, as were Cummins Big Cam and N14 engines. These power plants were chosen specifically for their torque output and durability under sustained heavy loads. Western Star built the 4800 on the philosophy of over-engineering. Frame rails were thicker than industry averages, crossmembers were reinforced, and suspension components were designed for extreme vocational use. This allowed the truck to handle high torque without twisting or long-term fatigue. Many modern trucks, optimized for weight savings and efficiency, simply are not built to endure this level of mechanical stress over decades. Another reason the 4800 could outperform modern tractors is its lack of electronic interference. Power delivery was entirely mechanical. There were no traction controls, no torque limiters, and no emissions-related derates. If the engine could produce torque, the driveline could deliver it to the ground. This made the 4800 exceptionally effective in heavy haul, logging, oil field, and construction applications. Western Star also allowed extensive customization. Buyers could spec heavy axles, deep gearing, multi-range transmissions, and oversized cooling systems. This flexibility meant the truck could be optimized specifically for pulling power rather than fuel economy or speed. In practice, this resulted in trucks that could start heavier loads and maintain pulling force on long grades better than many modern tractors. The Western Star 4800 never aimed for mainstream popularity. Instead, it earned its reputation quietly among professionals who valued strength above all else. Decades later, that reputation endures. In direct mechanical terms, torque delivery, structural durability, and driver control, the 4800 remains a benchmark for what a true heavy-duty semi should be. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.